You know, in two of the biggest industries on the planet, we're talking oil and construction, there are these invisible battles being fought every single day. Today, we're going to dive down to the molecular level to see how some really clever chemistry is actually winning them.
All right, so think about this for a second. What could crude oil, the black gold that powers our world, and concrete, the gray stuff that builds our cities, what could they possibly have in common? I mean, it sounds like a weird pairing, right?
Well, the answer is that they both face these massive industrial challenges that are super costly to deal with. But the solutions, they aren't what you'd expect. We're not talking about giant new machines or huge factories. Nope, we're talking about invisible fixes happening right at the molecular level. And it's all thanks to some seriously clever chemistry.
Okay, let's kick things off with our first big problem. It's crude oil's stubborn emulsion issue. And honestly, the best way to think about it is like the petroleum industry's least favorite food. Imagine a thick, gunky mayonnaise that just messes up the entire system. So, the technical name for this gross mayonnaise stuff is a water and oil emulsion. Basically, it's a mix where tiny, tiny little water droplets get trapped inside the crude oil. And they're not just floating around. They get so stable in there that they absolutely refuse to separate out on their own. And let me tell you, this stuff is a massive headache. It actually corrodes pipelines and equipment, it makes pollution risks go way up, and it tanks the quality and the price of the oil. But the real kicker is just how stable these emulsions are. I mean, we're talking about mixtures that can just sit there, all mixed up, for over a year if you don't do anything about it. A whole year. So what's going on here? What's holding these little water droplets hostage? Well, researchers dug in and they found the culprit. It's a heavy part of crude oil called asphaltene, and even more specifically, a type called interfacially active asphaltenes. These things form a tough, sticky film around every single water droplet. It's like they create a tiny, microscopic suit of armor. So, okay, how in the world do you break through that armor? Well, chemists are tackling this from two completely different angles. One is a super high-tech, synthetic approach, and the other, it's surprisingly natural and green. All right, first up, the high-tech fix. This uses a custom-designed molecule called JXGZ. You can think of it like a molecular assassin, engineered for one purpose. And the researchers, they gave it this amazing name, the dual swords synergistic effect. How cool is that? It basically uses two different chemical attacks at once to just slice right through that sticky film. So do these dual swords actually work? Oh, you bet they do. JXGZ can get to 100% dehydration. That means separating all the water out of the oil in just 4 minutes. 4. That is incredibly fast and unbelievably effective. Okay, now let's flip over to the other side of the lab, the green alternative. What we're looking at here are two different demulsifiers, B1 and C1. But these weren't cooked up through some complex synthetic process. No, these were formulated using common plant extracts. And the ingredient list here is just fascinating. It reads like a recipe from some kind of, chemistry cookbook. You've got cashew leaves and moringa leaves doing the heavy lifting. Then there's cassava starch to grab onto the water, and camphor to grab onto the oil. And finally, a little sodium hydroxide to help all those water droplets clump together so you can get them out easier. So the big question is, can a solution made from leaves and starch really compete with a fancy, engineered chemical? The answer is absolutely. In fact, in some tests, the cashew leaf formula separated water faster than a typical chemical demulsifier. That is a huge, huge win for green chemistry. All right, let's completely switch gears now. We're leaving the oil fields behind and heading over to the construction site. It's time to look at our second big challenge, concrete's seemingly unquenchable thirst. You see, for concrete to get as strong as it needs to be, it has to be cured. And traditionally, that just means keeping it wet, constantly, for days, sometimes even weeks. And as this quote points out, it's a super important part of building anything. But the big drawback is that a ton of that water just gets wasted as runoff. And that right there is the real problem. I mean, in a world where water scarcity is a growing concern, pouring millions and millions of gallons of fresh water all over our infrastructure just for most of it to run down the drain, well, that's just not sustainable. So this whole situation led chemists to ask a really brilliant question. What if
What if concrete didn't need all that water poured on top of it? What if it could somehow cure itself from the inside out?
And the solution they came up with is like a secret ingredient you add right into the mix. It's a chemical called polyethylene glycol 400, or you'll see it as PEG 400. And by adding just a tiny bit of this stuff to the wet concrete before it gets poured, well, something pretty remarkable happens.
The magic here is all in how PEG 400 works. It's basically a molecular sponge. It forms these hydrogen bonds with the water that's already in the concrete mix. This traps the water inside so it can't evaporate away. And sometimes they'll also add another chemical, sodium silicate, which is like an internal crack filler. It forms a gel that helps to self-heal any tiny fractures that might develop.
Okay, so you might be thinking, does this self-curing method actually work? Is the concrete weaker? But the data says not at all. In fact, it's the opposite. Normal cured concrete hits a strength of about 28.5 megapascals. But the self-cured concrete, with just a little bit of that PEG 400, it gets all the way up to 31.6 megapascals. That's an 11% increase in strength.
I mean, just let that sink in for a second. This is not a compromise. This little chemical trick doesn't just save an incredible amount of water, it actually makes the final product stronger. That's the kind of solution you dream about, right? Something that improves both sustainability and performance.
So from breaking down that sludgy oil mayonnaise to making concrete stronger without using a single extra drop of water, it's clear that chemistry is fighting and winning these incredible unseen battles all around us. And it really makes you wonder, doesn't it? What other huge invisible problems are being solved by clever chemistry right under our noses?